we're going to talk about DNA replication, and this is when DNA makes an exact copy of itself. It replicates. This is going to happen during interphase. And if you remember, it's actually during S phase of interphase. That's when DNA is synthesized. Okay, so DNA has multiple origins, so that means it can actually start in multiple places. But to help us understand it, we're just going to look at it in one place. So here's the DNA bubble. Okay, so the DNA, is a double helix. Okay, so the first thing that's got to happen, DNA has to unwind. Okay, so here's an enzyme at the first that's unwinding the DNA. Okay, so topsomerase is the enzyme that unwinds the DNA, and helicase is an enzyme that unzips the DNA. Okay, so helicase unzips DNA. In other words, it's breaking the hydrogen bonds in between those nucleotides. So helicase breaks the hydrogen bonds, while topsomerase unzips or untwists the DNA. Okay, if you look at DNA, remember that it runs anti-parallel. So what that means is there's a 5' side and a 3' side. So it's 5, and then there'd be a 3 over here, and a 3 and a 5 over here. All that's talking about is the way the nucleotides are laid down. So the nucleotides, where the 5 carbon sugar is, and then where the 3 carbon sugar is, it's just how it's laid down on the rung. But DNA runs, and that word is anti-parallel. So it runs opposite. Okay, so here's what you got to know for sure. DNA is built 5' to 3'. It's always built, always on both strands. DNA is built 5' to 3'. Okay, so this next enzyme is really important. We'll use green for it. Okay, so DNA polymerase DNA polymerase 3 actually. Lays nucleotides in the direction of 5 to 3. So it's going to start right here on the 3' end, and it's going to lay a 5, right? Because we said it's built 5 to 3. So it's going to lay DNA down. It's attaching nucleotides. So this is the most important enzyme. DNA polymerase 3 builds the DNA. So it builds DNA. In other words, it lays down those nucleotides. So like if this is a T, it's going to lay down an adenine nucleotide. So it lays it down 5' to 3' always. Okay, and we call this the leading strand because helicase is cutting in this direction and polymerase is laying in this direction. So it goes really easy. As soon as helicase cuts, DNA polymerase builds. Okay, on the opposite strand, it's not so easy. It's the lagging strand. Okay, remember we said that DNA must be built 5 to 3. Well, if this is a 3, then DNA polymerase is going to lay down right here. If this is a 5, it's got to lay down a 3. So it can't start there. It's got to start somewhere here. Okay, so on the lagging strand, it's got to be built this way because it's got to be built 5' to 3'. So on the lagging strand of DNA, DNA polymerase lays down nucleotides in the opposite direction of helicase. Well, this makes it slower because it's going in the wrong direction. So as soon as helicase cuts, it's going this way and has to keep backtracking. So instead of laying the nucleotides down one at a time. It lays the nucleotides down in fragments of nucleotides, like 10 base pairs, called Okazaki fragments. Okay, and an Okazaki fragment, named after, that's the man's last name who discovered it. They're laid on the lagging strand, that's segments of nucleotides. Okay, well, after those segments of nucleotides are laid, an enzyme comes in and attaches them. Okay, that enzyme name is ligase. So ligase stitches Okazaki fragments together. So ligase stitches the Okazaki fragments together. So I'll show you on this one. It just takes it and it stitches them together. Stitches them together like this. Okay, one more enzyme we're missing. RNA primase. Before the DNA can be built, RNA primase comes in and lays just a little bit of RNA down. So it'll be just a little bit of RNA laid down right here before the DNA can be built. So it's like when you're painting a room, you have to lay down primer. So RNA primase lays down the primase. Lays down the RNA primer. So RNA primase lays down RNA primer before this can all get started. Okay, so remember, all of this is happening so that DNA can make DNA. So this is DNA replication. So take a second, pause the video, and look, and go back and make sure you know what all these enzymes do.